Welcome to part 6 in this unit tutorial series, and in this video I'm going to make the player sync rotation script much more efficient by making it sync float values instead of the quaternions, and I'm going to implement that historical type of interpolation, and also just improve it so that the two quaternion interpolations aren't, I guess, fighting against each other unnecessarily. So I'll first of all change the script. I'm going to add in collections, so Unity using system.collections.generic, so I can use a list. And for my sync vars, they'll no longer be quaternions, so I only need to send a float across the network. No need to be that inefficient. And I'll also make hook functions with these as well. And I'm going to call this hook, which will be equal to on player rotation synced. That's what I'll call it. Okay, and also for this one as well, I'm going to call this one hook is equal to on cam rotation synced. Alright, with those done, next I guess I'll have, I think I'll remove the serialize field from the slurp rate, so I can just adjust it by script. I actually find that easier to do, just to adjust it right here inside of the script rather than in the inspector. Well, let's see, threshold, my cam, my rotations. So yeah, I don't need these as quaternions anymore. Just a float will do. And the value between when to send the next update, across the network, the next command, I think I'm going to reduce that to 1. So whenever the rotation changes by even 1 degree, send an update across the network. Well, to the server, which then syncs it across the network. Alright, so then next I will go ahead and implement the list, so private list, and it's going to be a float. And it's going to be a sync player rotation list is equal to a new list. Okay, done. Okay, then the next private list, and this is also a float, and this is going to be the sync cam rotation list is equal to new list. Okay, and I'm going to have a private float just like for the sync position in the previous video. A close enough value, so private float close enough, and say maybe 0.5 degrees, something like that. Maybe that's too much, don't know, won't know till I try it. And this one I'll serialize field it. Serialize field, private bool, use historical interpolation. Alright. Done. Okay. So I need to make something for these. I of course need to make some functions for these hook functions. So I will call these, let's say, well, they'll have the same name. So I'll just put it as client. Alright. And just put it void. Just paste in that name, and it needs an input, the float, and what shall I call that? I guess latest player rotation. I guess that would make sense. And then, okay, with that done, I have to now supply, you will make use of these values, so I'm going to say sync player rotation is equal to that latest player rotation, and then my sync player rotation list dot add, and I'll add that sync player rotation, which is now just a float. So what I'm intending to do, so what I'm doing is that, you know, the player, the parent only rotates, just ignore that, of course I haven't even finished. The parent only rotates in the y-axis. So I only want to send that value to the server, which then gets synced to the players, and then that value is going to be used for the interpolation. Then for the first-person character, which has the camera attached to it, that only rotates in the x-axis. So that's the only value I want to send. So I'm cutting away the other 3 values that make up a quaternion, and so saving a lot of bandwidth by doing that, especially since these are very frequent, I guess, bits of data that get sent across the network. So I thought it would be quite, I guess, important that I go ahead and implement this first before getting on to the hit detection and damage and all that. Might as well get the basics done first and then get to all that, which is also pretty basic too. Okay, so now I'll go ahead and get the other one, camera rotation synced. So void, paste that in so I don't make a mistake, because the names must absolutely match. Okay, float latest cam rotation. Okay, and then I will then say sync cam rotation is equal to latest cam rotation, and then the sync cam rotation list dot add, and then sync cam rotation. Nope, put in the wrong thing. All right. Okay, so with those 2 done, so I've got my hook functions at least, which will run on the clients whenever the server updates those values. I've got quite a few other things that need to change as well. I won't be doing this anymore, so this function lerp rotations, I won't be doing it like this. So I'll comment those out. I need to change that. Transmit rotations for sure needs to change. So let me think about that for a moment. Yep, that makes sense. Only the local player will send it. I think what I will do, because now I'm going to, it's not a quaternion at angle anymore, I'm going to be comparing 2 float values. And when I compare the 2 float values, one could be negative, one could be positive. So I'll take the absolute value then, which is just a positive figure after subtracting one from the other. And if it's greater than the threshold angle, then I will carry out the rest of this. So in order to do that, I should make a new function, and I'm going to make it a Boolean function that returns a Boolean. So bool check if say beyond threshold. Yeah, I think that's an appropriate name, except I haven't spelled it correct. And I'm going to supply it with 2 floats, rotation 1 and a float rotation 2 for comparing. And what will it do? So it's going to do a math f dot absolute and rotation 1 minus rotation 2. And if the result of that is greater than, whoops, not less than, greater than the threshold, then it's going to return true. Else return false. Okay. And now I want to replace this line of code to use that function, to use that check before running the command. So this is running on the local player, on our player in our game instance, and this is where I send the command to the server and tell the server what the latest rotation values are so that it can then sync it across the network. So I have to change this line now. So this is going to become, say, if check beyond threshold, the player transform dot local Euler angles. So I have to use the Euler angles. A quaternion is made up of 4 components, and none of them equate to like the degrees. So you use the Euler angles because those are the actual degrees that you see in the inspector. And I'm saying local Euler angles, well, just because it is the local rotation values that I'm most interested in. And of which one? It is the y value for the player because it's rotating about the y-axis. I'm only interested in that. And of course I'm comparing against the last player rotation value. Just like above, I need the OR as well. So if check for this, then of course use the OR. Check if beyond the threshold value, Then this one is the cam transform dot local Euler angles dot x, and the last cam rotation. Alright, so that should work just fine. Next I will change these, and I'm going to swap these around. And I'll put this up here. So the last player rotation is now going to be equal to this. So I'll just replace that line completely. And then, oops, just need to put the P there for player. And this one is the cam transform. Okay. Alright, so I have my values there. And next, now I need to run the command. So I need to change that because the values to supply to the command are different. I want to supply floats now. So I'll just supply the floats for the time being. I'll just say last player rotation and then last cam rotation. Alright, and I go to the command now. That's right above. And change these to floats. Okay. And that looks about right. In fact, I think there's nothing more to do. I'll just get rid of that debug.log statement there. I'll get rid of this line here too, because I believe I've done it correctly, and it looks fine. Okay. So then next, now that I've got the command working, and I know that the values will get synced across the network, and it's just a bunch of float values, I'll just make sure, yes, they're all floats, which is good. Then I need to actually lerp that. So I've got the transmit side working now. That'll be fine. I've correctly converted it all to float values rather than quaternions. Once I transmit, part of that is running the command. The command is okay now. And then after the command, then the sync vars will get synced across the network, and then the hook functions run, and the hook functions have floats, so those are okay now. So that means it is really just the lerping that needs to get fixed up now. So coming to my lerp rotations function, I need to change that. So if not is local player, what do I want to do now? I need to change it to look for historical lerping. So if use historical interpolation, then I run a certain function, else I run another function. And I think I'm going to make two new functions. One I'll call, say, ordinary lerping. So I'll just write it right here, void ordinary lerping. And that's it. And I will also make two sub-functions, so that way I can reuse the functions without having to, I guess, create a whole big separate function for the historical interpolation and for the ordinary lerping. So for that, what I'm going to do is I might as well write it here. So I'll say lerp player rotation. This is my intention. This is what I want to make, and it's going to take a value. So that would be the sync player rotation value. And I would also like to make another function called lerp cam rotation, and also supply this with a value, sync cam rotation. And now I might as well make these functions. So this one, I'll call that void lerp player rotation, and it takes a float value. And I guess for this, it's going to be a float rotation angle, say. Just call it something really simple. And what's going to happen with this one? I'm going to see, I have to reconstruct. See, I'm just taking a float value, right? So I need to create a vector 3 that represents the player's rotation now. So once I've constructed the vector 3, I will then use quaternion.lerp to lerp the player's rotation to that new rotation that I've made up. So what I will do is I'll just create a variable on the fly, vector3 player new rotation. I'll call it that, is equal to a new vector 3. And this new vector 3 will have 0 for in the x-axis. Then I will supply it with the rotation angle. No, not that. So rotation angle, and 0 for z. Okay, so now I've constructed the new vector 3, which is basically Euler angles. These are Euler angles. I will then actually implement the quaternion.lerp. So player transform.rotation is equal to quaternion.lerp, and where from is from player transform.rotation, and where to, it's going to be a quaternion.euler. I'm going to convert my player new rotation vector 3, my Euler set of Euler angles, into a quaternion. So player new rotation, otherwise I wouldn't be able to lerp. Okay, so now that I've converted that, then I'll say lerp rate times time dot delta time. Okay, and that should do that, and that's just too many spaces there. Okay, so that's that done. Now I want to create the other function. So this one is going to be called lerp cam rotation. Lerp cam rotation. It too is going to have a float, and I'll just call it the same thing, rotation angle. Okay. Right, so this one, I'm going to do exactly the same thing, but with a slight difference, so which you'll see in just a moment. So vector 3, I've got to give it a name, cam new rotation is equal to new vector 3, and this one is going to have rotation angle for the x-axis. Rotation angle, that's better, and then 0 and 0, okay. That's it, that's done. Now in this case, I'm going to say the cam transform dot local rotation, not the global rotation. Very important. It has to be the local rotation because it's a child game object. So as such, I want this to rotate relative to the parent transform. Otherwise, if I supply the global, it'll just be all confused. The rotation will just be all haphazard and all over the place. So it has to be the local rotation, is quaternion.lerp, and it's going to be cam transform.local rotation is what I'm lerping from, and I'll be going to quaternion.euler, and what is that going to be? Of course, the cam new rotation, and at what rate? The lerp rate times time dot delta time. Okay, so that should work fine. Coming back to here, ordinary lerping, I've got that implemented. So now I might as well plug that in, ordinary lerping. Okay, so I haven't gone ahead, I haven't made the historical lerping just yet, but maybe I can test it out. I probably can. Let me just check. It looks okay. Why don't I try it out? Can't hurt. Alright, and I'll call this build.exe, yes, and just build and run. Yep, just allow access. Alright, and coming over here, I'll just get rid of that. I still have my network simulation going on. Oh, and so the player's inside. Okay. And it looks like it's working to me. Let me have a better look. Let me say I get in a bit closer here in this view. Maybe about there, so I can see the players. And yeah, it's working. That certainly looks like it's working. And the slowness is mostly of the player inside the editor. That's just some editor slowness, really. And also, I guess maybe... no, it is, actually. And let me have a look. So, yes, I'm looking up, looking down, looking away, then looking towards. Yes, okay, looking over there. Yeah, okay, so it's working. So the ordinary lerping is working. And, of course, I want to now change that to the historical type of lerping. And let me just check something. The player's motion really did look very jerky there. Yeah, so that makes sense because I turned off the historical lerping, so I thought it did look a bit funny. Let me just double check that nothing has changed, that I didn't ruin anything. Okay, and coming back. Alright. Yeah, that's a lot better. Let me just put that volume down. That's the footsteps. Yeah, okay, so that's fine. That's looking a lot better and looking just fine. So just now I need to implement the historical interpolation for the rotation. And while I'm at it, I should turn off that debug.log on the player sync position. There's no need for it anymore. I've gone through all that and I'm happy with it. So I'll just turn that off, comment it out. And it does take up a fair bit of resource as well. It uses up several milliseconds every time it's used up of processor power, I guess, or time rather. Okay, so now for the historical interpolation, I need to make a new function. So my intention here is to run a function called historical interpolation. Oh, it's trying to be very helpful there, but I know I don't want to do that. I want to actually put in a wrong name and then go ahead and make the name here. So, okay. So I don't need to supply any inputs. I'm going to use my previously made functions. So I'm going to say, just like with the sync position, first of all, there has to be something in each of the lists before I actually do anything, before I try to interpolate, otherwise I'm going to get an error. So if sync player rotation list.count is greater than 0, then in that case, then I will lerp the player. So I'll lerp the player rotation. So I'm using the function that I just made below, and I'm going to supply it with the sync player rotation list first item. Okay. And like the sync position script, if I'm close enough to that rotation value, if the lerping has gotten close enough, then knock it out of the list so it can move on to the next item. So if mathf.abs absolute player transform dot local Euler angles, so I'm going to compare this local Euler angles dot y minus the sync player rotation list first item is, I got my brackets okay. Yes, I do. Okay. Is that, then if it's less than the close enough value, then in that case, knock it out of the list. So a sync player rotation list dot remove at first item. Okay. And that is that for it. And I will also, I could put a debug.log statement in there just to see how many items are in the list. I'll do that if it doesn't look right when I'm running it. So if sync cam rotation list, hang on, am I not doing something right? If sync, yeah, I'm not typing right, that's what I'm not doing right, dot count is greater than 0, then in that case, I'm going to say lerp cam rotation and supply it with the sync cam rotation list first item. Okay. And it's just like above, maybe I can just copy paste it just to speed things up a little bit. So if in this case it's the cam transform dot x is the angle I'm interested in, and this one is the sync cam rotation list first item, then the sync cam rotation list, remove that item. Okay. And I believe that is all. I don't think I need to do anything else. I've actually already updated the function. I can get rid of these old items here. No need for them. I think that might be too high. It's just my guess anyway. I'll set it to 0.3. It might be too snappy. 15, maybe 15's okay. You know, why don't I put two debug.log statements here? Debug.log, and I'm gonna say the count of the list. So sync player rotation list.count.toString. Okay, and plus I'll just say this is the sync player rotation list count, and I'll copy this and put it down here as well. And I will say this one is the sync cam rotation list dot count dot toString, and I'll just copy that. Alright, and I believe I'm ready to go. So build and run it. Oh, and I found something rather obvious, which is to come back to the player and just check use historical interpolation. Alright, done. So build it again. And just move over. Okay. Okay, looks like it's working actually. Is it perfect? No, it isn't. But the important thing is it is actually working. The rotation appears to be alright to me. Let me have a look here. Let me say if I jump up on the cube so I can... And I can see the messages are there. It is actually, I guess, working. Yeah, it is knocking the items out of the list as the rotation is being achieved. And yeah, it's good enough. I guess it's not too big a deal if the rotations look a bit funny. It's more important the player movement looks about right instead. Yeah, the player movement looks very smooth. The rotation still looks a bit jerky, which means that the values need tweaking to get them to look smooth. Maybe I need to send out, update the rotation more frequently. You know, maybe a difference of one angle is too great. Maybe it has to be smaller than that. Maybe the close enough value is no good. But then again, there's something funny here, actually. What is this? Sync player rotation list dot count. No, it is actually moving too slow. That's the problem. So actually that was very helpful that I put that on. So this is syncing too slowly. That means my lerp rate is way too low. So say if I put it to 20 and close enough, I'll leave it at that 0.3. Maybe put it to 0.4. Alright, now I run it. So of course the position and rotations will be slightly out of sync between the games, but I'm not expecting that to be like a big problem at all. Ah, whoops, a timeout. Yeah, I really need to increase that timeout or reduce the lag. Alright, and once again that didn't work. So let me just redo that and change that in my network manager. Just set it down something like 150. Oops, not 400. 150. And build and run again. Alright. Okay, so that does look quite a bit better. And also I can see that the list is not growing so fast that it just can't keep up at all. That's better. So yes. Alright, so that's it. So pretty much the values just have to be tweaked until it comes to something that looks reasonably smooth. And then that's pretty much it. Otherwise, the framework is there, and it is basically working, and it's much more efficient than the previous situation of having to send the whole quaternions, I guess, every time the rotation changes, which was pretty inefficient, actually. So now it's just 2 float values, so 2 pieces of data instead of 8 pieces, which is much, much better. Okay, so thanks for watching, hope this helped you, and in the next video that should be about making the players unique, and then after that hit detection.